Let's talk about coordinate systems for subspaces of Rn. So first the definition. Suppose I have a basis B1, B2 up to Bp for a subspace H. For vector x in H, the coordinates of x relative to this basis are the weights C1, C2 up to Cp that are required to express x as a linear combination of the vectors in the basis. The vector notation x with square brackets around it and a subscript of b, consisting of the weights c1 up to cp. This is a vector in Rp. This is called the b-coordinate vector of x. So one way to think about coordinate systems is they give us a different way to describe points in our space. So let's take a look at an example. Suppose I'm looking at a subspace H in R2, and H is the span of the vector 2, 1. So it's the line shown here. And suppose X, the point I'm thinking about, is the point 10, 5. If I choose basis consisting of the vector 2, 1, then X in B coordinates is just this vector C, where C has the property that C times 2, 1 is X. And so that tells me that the b-coordinate vector of x is just the vector 5. Well, if I choose a different basis, so let's choose basis C, which is given by a single vector 4, 2, then x in C coordinates, the C-coordinate vector of x, is just this vector d, where d has the property that d times the vector 4, 2 is supposed to give me x. And so I can just solve and see that the C-coordinate vector of x is 5/2. So now let's go through example 1 on page 154 in a bit more detail. So we'll let V1 be the vector 3, 6, 2, and V2 is the vector -1, 0, 1, and x is the vector 3, 12, 7. Basis B is just V1 and V2, and H is the span of V1 and V2. And so it's easy to check that B is a basis for H because the vectors of B are linearly independent. So the question is the vector x an element of H? And if yes, find the b-coordinate vector of x. So that's asking us to find a C1 and C2 in R, if they exist, that have the property that C1 V1 plus C2 V2 is x. Right? Because we want the weights that express x as a combination of V1 and V2. So if C1 and C2 exist, then that tells us x is a linear combination of V1 and V2, and so x is in the span of V1 and V2. Otherwise, x is not in the span. So we set up the augmented matrix in order to compute these scalars, and we set about with the row reduction. So let me just zip through this. Assuming my arithmetic is all correct, in reduced echelon form, I end up here. I put boxes around my pivots, and it shows me that C1 is 2 and C3 is 3, which tells me the b-coordinate vector of x is 2, 3.